Hi everybody, this is going to be a help video to check your answers on all of the odds, starting on page 84 for this mixed practice type 3. So this is going to use all of our skills, adding and subtracting, multiplying, dividing, composition, a couple domain questions throughout. So let's get right into our questions here. Now I am going to move through these one at a time, but please remember that you always have the ability to press pause and finish trying something on your own if you didn't actually get it the first time. Or press pause and then go back and listen to it again. So remember, don't just let it play all the way through. Please pause when you need to, or challenge yourself to using it to get a hint on one that you were stuck on. You finish trying it and then you can press play to check your answer. Starting with this first set of questions, we're asked to determine the domain of the following functions. So when I look at number 1, in my mind, I see that this is y equals mx plus b, which means this is a linear function, and my domain is going to be all real numbers because, actually put all that in a box, because the picture of this graph, think back to 9th grade, right? Lines go both ways forever and ever. There's going to be no restrictions on that function. So the domain is all real numbers. Number 3, on the other hand, think back to when we did our discovery activity. I'm just going to draw you a quick little picture. So when we did that activity, we saw that with any kind of even root, like a square root function, the graph did not go forever and ever. It had a clear starting point and then it went a direction. So this function definitely has a restriction. When I come in from the left, notice I hit a value. So to find that value, we can do some algebra, because clearly you're not given the graph here, so there must be a way to do it just from the equation. We talked about in class how cannot take an even root of a negative we can't take the square root of a negative. So we focus our attention on what's underneath the radical. Whatever's under here can't be negative, meaning it has to be positive. So to figure that out using our algebra, we take the expression that is underneath the radical and we set it greater than or equal to 0. Because we're saying this has to be positive. And now we can solve for x. To solve for x, we will subtract 15 from both sides. We get 3x is greater than or equal to negative 15. And then we will divide both sides by 3. And we get x is greater than or equal to negative 5. So for number 3, the domain is all real numbers. X is greater than or equal to negative 5. On to number 5. We're given these two functions, f of x equals 3x squared minus 3x plus 4, and then g of x equals 5x minus 1, and we're asked to perform the following operations and determine the resulting domain. So I look at number 5 and I see that I have subtraction happening. F of x comes first, so let's write that first. F of x is 3x squared minus 3x plus 4. The key with subtraction, folks, is to make sure that you are using parentheses for that second piece. Because when I plug g of x in here, which is 5x minus 1, need to distribute the negative, or a negative 1, if that helps you to see it. This negative has to be distributed to every single term in here. So that's why I have to use parentheses, because now this will be 3x squared minus 3x plus 4 minus 5x plus 1. And if there were more terms here, I would have kept sending in that negative. So subtraction, have to use parentheses. We're now ready to combine like terms. Remember, like terms are the same variable raised to the same power. So as tempting as it might be to combine these two right here, I cannot do that because this is x to the second power. This is x, but notice there's no 2 right there. So let me keep looking. I see negative 3x and a negative 5x. That I can do something with. So we have 3x squared minus 8x, and then positive 4 plus 1. I can combine those like terms, and I get plus 5. For the domain, I recognize that this is a quadratic. And remember, quadratics look like a U shape. These have no restrictions. When I come in from the left, I hit an arrow. When I come in from the right, I hit an arrow. So it's going to go forever and ever this way and forever and ever that way without any kind of problems. So automatically, my domain is all real numbers. Good job. All right, let's move on to number 7. It says, use k of x equals 2x minus 9 and m of x equals x plus 3 to perform the following operations and determine the resulting domain. So for 7, I see that this is multiplication. So we're going to use parentheses, have to use parentheses. We're going to put 2x minus 9 in parentheses times x plus 3 also in parentheses. As soon as I let my brain see that, I realize I need to distribute, and I'm going to use my arrows to help. So 2x times x is 2x squared. 2x times a positive 3 is a positive 6x. Nowhere else to send these arrows, so now we go and send in negative 9. Negative 9 times x is a negative 9x. And negative 9 times a positive 3 is a negative 27. Now I am ready to look for some like terms. I see no other squared terms, but I got this positive 6x and this negative 9x. That I can do something with, resulting in an answer of 2x squared minus 3x minus 27. Once again, this is a quadratic. So our domain will be all real numbers. This has no restrictions. Number 9, we are asked to subtract. M of x will come first. I actually didn't need to put that one in parentheses, but you can if you want to. X plus 3 will come first, minus, it's the second function. You really have to make sure it gets in parentheses, because again, this negative sign needs to be distributed to all of the terms on the inside. So this is going to be x plus 3 minus 2x plus 9. Combining like terms, x minus 2x is negative x, and then I can also do positive 3 plus 9 is a positive 12. The highest power here is 1, that's like an x to the first. So this is like mx plus b. This is a linear function. My domain is all real numbers. For number 11, we're still using the same functions up here, k and m. It says k of x all squared. K of x is represented by 2x minus 9. So where I see k of x, I can actually write 2x minus 9, and then it's being squared. So I'm hoping from last year we remember that if we see this notation, 2x minus 9 all squared, we cannot just go like this and send in the 2 like that. Nope, can't do that with exponents. The official math way of saying that is that you cannot send in a power over subtraction. If this was multiplication, so maybe I think sometimes people think like this. See how this is 2 times x to the 9th squared? That's when you can do power of a product and multiply the powers. But notice, multiplication, no problem. Here, that's subtraction, you can't do that. Instead, we have to realize 2x minus 9 all squared is saying 2x minus 9 times another 2x minus 9. We're multiplying 2 of them together. So let's use our arrows. 2x times 2x is a 4x squared. 2x times a negative 9 is a negative 18x. Now let's send in negative 9. Negative 9 times 2x is another negative 18x. And then last but not least, negative 9 times negative 9 is a positive 81. Checking for like terms, we can combine this negative 18x with this negative 18x, and we get 4x squared. I'm not sure about 18 and 18. We're adding in the negatives, so I can write 18 plus 18 and then just make the answer negative. So 8 plus 8 is 16, 36. So we get minus 36x plus 81. This is a quadratic. Domain, all real numbers, no restrictions. It's that U shape. Very good. Let's see. Moving on to number 13. Composition. Given f of x and g of x, find. Now remember from class we can say this is g of f of x. If we can say it right, we're more likely to set it up right. Our strategy is to write the starting function first. So when I look left to right, this says g of. So I know I'm going to write g first. G of x equals 2x plus 1. And I draw a line down my equal sign. And then I ask myself, what's getting plugged into g? What's the input? Well, I see g of f of x. That is what we are plugging in. That's the input. So I go and I say, well, what is f? F is given to be 3x minus 7. So over here, to keep track of that, we'll write g of 3x minus 7. So there's really no math happening on this left side. We're just using it to help us keep track of what we're going to plug in. This first function, by writing g first, is kind of like our guide. Because now, wherever I see x, we know that we are going to be plugging in, substituting in, 3x minus 7. So this is going to be 2 times 3x minus 7 plus 1. And for emphasis real quick, my original function, just to make it stand out, was g of x equals 2x plus 1. Now we're saying, instead of g of x, we're saying g of 3x plus 7. So now wherever there was an x, 3x, I'm sorry, I think I said plus 7, my bad. G of 3x minus 7. So now wherever I see x, I know I need to plug in 3x minus 7. From there, we're back to our algebra skills of distributing 2 and getting 6x minus 14, and that plus 1 comes down. 6x minus 13, and we are all done. Same process with number 15, just different functions. G of f of x. So g is still coming first, so I write g of x first. G of x equals x squared minus 2x plus 10. That's going to be my guide. And I'm going to draw a line down the equal sign. This is what I'm going to be plugging into. And I'm just going to put it right here. We're asked to find g of f of x. So that's how I know that f of x is the input. So I don't have to guess what that is. I just go look and I say, ooh, look, f of x, I am told, is x plus 6. So this becomes g of x plus 6. So I challenge you, if this one was a little bit of a struggle, g of x equals x squared minus 2x. Wherever we see x, we need to plug in x plus 6. So if you did do this one, press pause and you try plugging it in, and we'll see if we match. This is going to become x plus 6 squared minus 2 times x plus 6 plus 10. And using my colors again, oops, I want to change my color. So if you look at the blue and now you look at the yellow, see how closely that lines up, literally exactly? Wherever there was x, that input now became x plus 6. So x squared became x plus 6 all squared, minus 2x became minus 2 times x plus 6, and then the plus 10 is along for the ride. From here, we are fully relying on our algebra skills. So we know that x plus 6 all squared will mean x plus 6 times x plus 6, and then I can say minus 2x plus 12. I just distributed this negative 2, and I brought down the plus 10 equals, and now we're going to use our arrows, so x times x is x squared, x times a positive 6 is positive 6x, and then positive 6 times x is plus 6x, and then last but not least, 6 times 6 is a positive 36. Now we're just bringing everything else down, so minus 2x is still here. If you want, you can combine these like terms right away right here, which would be plus 22. Our last step will be to combine any like terms we see. There's nothing else like x squared, so I will bring that down, x squared. And then I see a positive 6x plus 6x, and then here minus 2x. I can combine all those together. 6 plus 6 is 12, minus 2 is 10, so plus 10x. And then last but not least, a positive 36 plus 22 is a positive 58. Right. On to 17. Given f of x and h of x, find f of x times h of x. We want to make sure we use our parentheses because we're going to be multiplying. So it's going to be f of x first, 8x squared minus 3 times 2x to the third plus 4x. And now let's use our arrows. 8x squared times 2x to the third. 8 times 2 is 16. And when I do x squared times x to the third, we add the exponents and get x to the fifth. 8x squared times positive 4x will be plus 32x to the third power. And you can kind of visualize that, right? Because this is 2 x's multiplied together times one more is 3, which is why we can have that little bit of a shortcut of just adding the powers, because the powers represent how many x's are there. We are not done yet though, because we just finished sending in 8x squared, but now we need to send in the negative 3. So negative 3 times 2x to the third is minus 6x to the third. And then negative 3 times a positive 4x is a minus 12x. Last step will be to combine like terms. Same variable raised to the same power. Now notice, all of these have an x term, but only these two have the same power. So I can combine these two. Everything else will stay. So we get 16x to the fifth plus 26x to the third minus 12x, and we're done. So just to stress the point, when we've got multiplication, the key is that we use a double set of parentheses, set around each function, and then correctly use our arrows. Very good. Moving on to number 19. It says g of f of 7. So as a reminder, when I have a value on the inside like this that I can actually do, we're going to start there. I can actually calculate f of 7. So let's find f of 7 first by itself. That's going to be negative 2 times 7 plus 11, which is negative 14 plus 11. which is a negative 3. So really what just happened is now instead of saying g of f of 7, we're really saying g of negative 3, because I just figured out that f of 7 is negative 3. So wherever I see x, I will plug in negative 3. So now I have 5 times negative 3 plus 4, which is negative 15 plus 4, negative 11, and I am done. So my answer, my final answer, is negative 11. All right. SAT practice. Show your work or explain how you got your answer. 21. We're given this expression here. It says, if the expression above is written in the form ax squared plus bx plus c, in which a, b, and c are constants, what is the value of a plus b plus c? Awesome question. So let's think about what this is asking us. It says first, if this expression is written in this form, all this means is simplified as much as possible and in standard form. Let's see how we can apply that, because this is definitely not simplified. We can really do some work here. First, I see I'm subtracting, so this negative sign will get sent into all of those. This beginning part is going to stay just like it is. 2x squared minus 3x plus 1. Now let's send in the negative. Negative times negative is positive, so that becomes plus 2x squared. Negative times negative is positive, so that becomes plus 3x. Negative times a positive is negative, minus 2. So notice these three values, if I just circle this for a second, you don't need to circle this, but I just want to draw your attention to it. Look what happened to the signs. The values themselves stayed, but this went from negative, negative, positive to positive, positive, negative. That's what happens when we distribute in a negative sign. Now let's combine like terms. I see that I have 2x squared and a positive 2x squared. That makes 4x squared. Negative 3x and a positive 3x, those cancel out to 0 because negative 3 plus 3 is 0. And then last but not least, positive 1 and a negative 2 is a minus 1. So this is what I have for my answer, but none of these answers look like that. So let's go back and reread. We've accomplished this. We've simplified it as much as we can. It's in highest power to lowest. But it says, what's the value of a plus b plus c? So if I rewrite ax squared plus bx plus c underneath, and now I'm going to line up my answer, 4x squared. I have no middle term, so I can say plus 0x, and then minus 1. It helps me to see that a is 4, b is 0, and c is negative 1. So really what this is asking me to do when it says a plus b plus c is adding up these coefficients. 4 plus 0 minus 1 equals 3. So my answer is B. Really neat question that builds on a ton of prior knowledge and really thinking about what it's asking. A lot of SAT questions are not hard. Like, you know how to do all this algebra. It's just making sure we understand what the question's asking. So if you want to kind of apply that thinking to number 22 in advance, you're more than welcome to. In the meantime, let's go over here and look at number 23. So the same idea applies to number 23, where it may look, whoa, this is crazy, but we have all the skills that we need to do it. So I have this function f of x and this function g of x, and it says, what is the value of f of g of 3? So I see that it's giving me something to evaluate. That's where I'm going to start. Doesn't matter what these look like. I know that with composition, if it says f of g of a number, I'm going to take care of that inside piece first. So g of 3 equals 2 minus 3, which is negative 1. So f of g of 3 has now become f of negative 1. And wherever I see x in this function right here, I plan on putting in a negative 1. So that becomes 1 minus 5 times negative 1, all divided by 2. 1. Negative 5 times negative 1 is a positive 5. I don't want to interfere with this next question, so I'll go across. That's 6 divided by 2, which is 3. Making the correct answer D. So we have done examples just like this, and this is an actual legit SAT question that you can use your composition skills to get right on the SAT. And that rounds out the odds from this practice. So any questions, please shoot me a remind, and happy studying because the test is coming up. So if you have some free time to get working on the evens, that would be fantastic. See you guys in the next class. Bye.